So where I was walking on my roof, I was showing you those two panels that are in parallel. There's a MC4 connector that's joined together with an MC4 style, and then those are joined together on a Y connector that combines two males, two females together. The power is then wired into this Blue Sky MPPT charge regulator. Negative side is on a 30 amp fuse, and then the battery side is going to these copper plates. So that's the positive side, that's the negative side. And the copper plates are also receiving power from this regulator here and these other ones. And then what I have here is this amp meter shows the amount of power flowing into the battery banks. So all of the power being shunted to being delivered to the batteries from the solar is combining at this one point. It's going to get noisy. I'm going to turn some things on so you can see the amount of power will change. So it'll let more power in through to the battery bank as you're using power from the batteries, using it with this inverter here. So that inverter is connected to this power strip right here. And between the power strip and the inverter is this metering device here. So it shows me how much AC power that I'm using over time. It has a menu, different menu systems for data logging. It'll show you how much power it's costing you, and over your time, how much time you've used it, how much it's costed you, how much it saved you. Me, actually. But this would be, if this was on the grid, it would tell you if you had an appliance on how much the appliance power uses. You can set it for different pennies, you know, per kilowatt hour. You can set it and it'll keep a log of it. And it's showing me my kilowatt hours used, 42. Time. And now it's not much. That's the voltage coming from this right now. So I'm going to show you the power that's rated, that it's running at here. Let's see. Okay, that's running 60 hertz. I'm using 185 volt amps. It's running at 166 watts. So all of my appliances right now, that's how much wattage they're using. And it's taking 1.61 amps for my appliances, including that drill press you're hearing running. And then I have an air bubbler here. It's running in this worm tea. Anyhow, that's how it's working out. So the other thing I was going to show you was the switches. I have a switch that's on-off the negative side of the battery and on-off the negative side of the solar. So I can choose to turn it off if I want to. I can turn the solar panels off. Yeah, it should just show battery voltage. And then I can turn the battery side off also on this side. So I'll leave that on. See, that's how much power the solar panels are producing, and then it'll come down to allow the power through at a certain voltage. Should shift it. Well, it's drawing power from the panels, and then it's determining how much power to let through. It senses the power in the battery bank. Yeah, it's just the different kinds of charging depending upon how much power is coming through or how much is needed. So we'll turn both of these on. Sorry about the noise. I just wanted to show usage of the power. You can see the needles rising, 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 rising. I'll just turn everything off so you can see. You can see when I put a load on it what happens. So now there's the batteries aren't being used, being required. The power isn't being required from the batteries as much, so that the solar MPPT is not allowing that power to go through to the batteries. So if I turn these on, it'll let more power through. Flowing now, I'm allowing more solar power from the solar panels to flow into the battery bank. That's what these do. Is they allow more power. They meter the flow of the power. They keep the flow of the power at a level that it won't damage the battery bank. So, and also this is bringing the voltage level down. So even though I have a 24 or a 12 volt battery bank, it's bringing the voltage down to that power level safely without damaging the battery. Signing off.